audible? If audible, please confirm yes in the chat. Okay, if audible, please confirm with an yes in the chat. Okay, thank you, Avani. Okay. Now, before I start, I will share my screen. Okay, you guys can see my screen, right? Please confirm in the chat. If my screen is visible, please put yes in the chat. Okay. Thank you, Kirtana. Thank you. Okay, once again, hello everyone, and warm welcome to the day 8 of our Data Science and AI add-on certificate course with industry internship. Thank you all for joining today. As you know, I am Alphy Mathew, research engineer at IPSR Solutions Limited. So today we are continuing with the day 4 of our machine learning session. Welcome once again to our session, and today we are going to explore another very important but very simple yet powerful machine learning algorithm called K nearest neighbors, or KNN for short. So KNN is one of the most beginner-friendly algorithms because the idea is very natural in KNN. Very simple idea and very natural idea. So let's dive in and build the KNN model step by step. Okay. So as I mentioned earlier, KNN stands for K nearest neighbors. Okay, K nearest neighbors, KNN. So this is a supervised learning algorithm and is mainly used for classification. Sometimes it can be used for regression also, but main aim or the main application comes under classification problems. Okay. It is the most beginner level machine learning task friendly algorithm is KNN. Very simple. Its logic is very simple, not very complicated one. Just finding the similarities. Okay. If I ask you some like this, if you had to take advice about choosing a restaurant, suppose you need to. Okay. No issues, Chris Gupta. For today's class is not the continuation of yesterday's. It's the last class we were discussing about SVM, Secure Vector Machine. You can listen it later in the LMS. For continuing in today's session, no need to watch the previous one. Okay, no issues. Okay, thank you. I was asking, like, if you had to take an advice about choosing a restaurant, you need to choose a restaurant. And would you trust, if I am asking you, would you trust, if I am giving you an option A, 10 random people from the internet, or 3 of your close friends? Okay, you want to choose a restaurant and you need to get opinion from some random people in the internet, or 3 of your closest or your close friends. From whom you will take the opinion? Put it in the chat. 10 random people in the internet or your close friends? Okay, close friends. Others? Maria, you will take from 10 random people from internet or close friends? Okay, close friends. Yes, we will be taking opinion from close friends rather than from taking opinion from 10 random people in the internet, because we have more access, or we have more genuine or trust in our close friends. Okay, this is exactly idea that is working in KNN. You trust your nearest friends, that is nearest data points. Here in our case, it is not friends, it is data points. Okay, so we are trusting your nearest friends or the closest data points more than far away strangers. This is what we can this is what we can say that KNN works based on the idea of similarity. Hmm? It assumes something very simple. Similar things exist close to one another. Okay. So the assumption behind KNN algorithm is that similar things exist close to each other. In other words, if two data points are very close in the space, when we plot or when we represent the data points or our data in a plot, then if the points are very close to each other, then they are similar. It is the idea. Okay, so in KNN, the smaller the distance between the 2 points, more similar they are. So how the similarity is calculated? The similarity is calculated by uh, calculating the distance. If the distance is more, then they are similar. If the points are close to each other, then those points are similar. That is the idea behind, major idea behind the KNN algorithm. Okay, so when a new data point comes in the KNN algorithm, then this algorithm look for k closest neighbors and performs a majority voting. So today we are going to see how this majority voting or how this k closest neighbors are found using KNN. So KNN basically works like this. You please look around, then check your neighbors and follow the majority. That is the principle of KNN. Look around, uh, look around and check your neighbors and say, then follow the majority. What will be the majority? Go for that. So KNN is also known as majority voting algorithm. Okay, so we are one by one going to find how this similarity is calculated, how this KNN do this principle. Okay, so if we want to guess something about a new point, what we want to do? We want to look at the nearest point. That is the theory. Okay, that is a simple assumption or theory that we are discussing in KNN. That is, if we want to guess something about a new point, what we want to do? We want to look the nearest point. So KNN predicts the label of a new data by checking the label of the key closest neighbors from the training data set. So let us understand how this k closest is taken by step. Okay, first we will be discussing the step, then we can do it by using one simple example. Okay, so there are basically 5 steps. We can convert it into 5 steps and explain how KNN works. The first step is we need to choose the value of k. Okay, we need to choose the value of k. Then what is this k? K simply means how many neighbors you want to consider. Okay, K simply means how many neighbors you want to consider. For example, if I am giving, or if I am setting K is equal to 3, suppose I have chosen the value for K as 3. It means that we look the 3 closest data points for the new data, and according to that 3 closest data points, we will decide the label or the class of the new point. I repeat, if k is equal to 3, it means that we look 3 closest data points of the new point, and the class label or the category of the new point will be the majority category of this 3 closest points. Okay, so first step we want to do is we need to choose a value for k. Okay, then coming to the step 2. In step 2 we calculate the distance from the new point to all the existing points in the dataset. We will calculate the distance from the new point to all the existing points in the dataset. Then you may be wondering how this distance is calculated. It's very simple. The basic or the default distance metric we use to find the distance is the Euclidean distance. You may have been heard in your maths or statistics classes, etc. how this Euclidean distance. There is a formula to find that. We will be finding the Euclidean distance between 2 points. Okay. Then in the third step, we will be sorting those distance in the ascending order. Okay, we will be arranging from smaller to largest. Why smaller to largest? Because we need the similar points, closer points. Closer and similar points means distance will be less. So we need to sort in ascending order, smaller to the higher one. Then in step 4, what we do is that we want to select the nearest k neighbors. So we have suppose we have chosen k as 3. Then we want to take nearest 3 neighbors. Okay, if k was 5, then we want to take nearest 5 neighbors. Okay, then in step 5, we predict the output of the new point by using the majority rule. Okay, so here I have been explaining it very simply to the base, but from next slide onwards we will take an example and we will find how this is happening, and we will see both pictorially and also in mathematically. Okay, so remember that if among 5 neighbors, 3 belongs to class S and 2 belongs to class No, then our majority voting cases, yes got 3 votes. So KNN will be predicting S. If you are getting any confusion, no issues, we are going to each step one by one now. Okay, so here we are going to explain how actually this is happening pictorially. Okay. On the screen, you can see a scatter plot. You can see an x1, x2 plot, and some data is plotted in this image. And you can see 3 classes. Suppose we can call this as lime color. We can call this as green class, and we can call this as orange class. Okay, lime, green, and orange. So there is a new data point here. This is the gray is the new data point. Our problem is we need to classify this gray point to either lime or green or orange. We need to find which class it belongs to. This is our problem. Okay. So to answer this, we are going to use what? KNN algorithm. For that, first step, we know we need to choose the value of k. So the first thing we need the k, that is, what is k? K is the number of nearest neighbors we want to look at. For example, for this case study or for this example, we have been set our k as 4. Let our k be 4. So we are just choosing it as random starting point. For now, I am just given it as k is equal to 4, which is random. Randomly, I am giving a number. Then why does the k matter? Because k does how many nearby points will influence our prediction. So with the k equal to 4, we will look at the 4 closest points around the gray circle, and based on their classes, we will predict the class of our new point. This is our idea. Okay, so we start by observing the data, then we choose k, then we go move to the next step, that is our second step, calculate the distances. Okay, in calculating the distances, what we'll do is that we will calculate the distance between the new gray point and all the other points present in our dataset. We will calculate the distances between this gray point and this lime one, then this one, then this one. To each point, we will calculate the distance between the new point and each point in the dataset. And how this distance is calculated? We are using by default. There are so many distance measures are there to calculate the distance. By in the beginner level, the default one, the simple one is Euclidean distance. Then how this Euclidean distance is calculated? Suppose you have 2 points, A and B. A have the coordinates, suppose it has x1 and y1, and B have the coordinates x2 and y2. Then distance between, the straight line distance between A and B is calculated using Euclidean distance as distance D is equal to x2 minus x1 the whole square plus y2 minus y1 the whole square, the whole root. The root of x2 minus x1 the whole square plus y2 minus y1 the whole square. When we do this formula, we will get the distance between the point A and B. Okay, so here in this second step, we will be calculating the distance between the new point and all the other points in the data set. Okay, so as I already mentioned, please note that not only Euclidean distances are available, Manhattan, Minkowski, and so many distances are there, but most common and default distance we use is the Euclidean distance. Okay, then once we calculate all the distances, we move to the next step, and our next step is sort the distances. Okay, suppose we have got the distances as like this. Each distances, there are so many distances you can see, 2.1, 2.4, 3.1, 4.5. So in suppose we have been arranging that in the ascending order, means smaller to higher, or the farthest one, that is the closest distance to the farthest distance. So I have only given the 4 points here. Then from this, after sorting the distances, what we want to do is we need to choose the first K from this list. First K in the sense we have been set K as 4 in the beginning. I think you remember that. We have been set to K equal to 4 when we started this one. Look, we have been set to K equal to 4. So after sorting, we need to take first 4 closest points. Those closest points are listed in this image. Okay, these 4 neighbors are the most similar to the gray point when we are ordering them in ascending order. Now, once we have the 4 neighbors, the final question is, then which class this gray point belong to? We need to find that. For that, the last step comes, that is the majority voting. Okay, here we can say that out of the 4 neighbors, first nearest neighbor, this is the second nearest neighbor, this is the third nearest neighbor, and this is the fourth nearest neighbor. Why only 4? Because I have chosen k equal to 4 at the start. So out of this 4, 2 says that, 2 neighbors says that the gray point class label as line. Okay, one neighbor says that green, and one neighbor says, other one neighbor says that orange. So we calculated the majority votes. That is happening here. In after majority voting, line got 2 points, and green got 1 point, and orange got 1 point. Okay, so all of the 4 are voting for each class of gray point. Line is voting, green is voting, and orange is voting. Here, who wins? Line wins. Okay, because line has 2 votes. So, according to KNN, the gray point will be classified as line. So, the KNN, what the KNN will do? So, KNN will think that, so the green point has got, gray point got 2 votes in the line category. So, our new point gray will be classified as line. So this is very simple according to the similarity and just sorting and choosing the K set in the beginning and using majority vote, we are finding the class labels. Okay. Okay. Now, using diagram, we have explained it clearly. If anybody have any doubts in that, we can now look into mathematically. Okay, you may be thinking how these maths are going on. For them to get it more understandable, we have added a short data set and we are mathematically doing that. So the same steps but showing mathematically. So suppose we have a mini data set, very small data set with 2 input values, weight and texture. And our output label is like apple, orange, apple, order. We have 4 observations, weight 150 grams and texture 1. 1 means smooth. Smooth. Then it is an apple. Then for 170 grams, texture is again smooth. It is again an apple. Then 140 gram and the texture is 0. 0 means rough. If it is rough, then it is an orange. This is our data. So there are 4 observations. And we want to predict a new fruit. That is our new fruit's input weight is 160 gram and texture is smooth. That is 1. We need to predict either it is an apple or an orange. Okay. So we need to compare this new fruit with all the food data present in the existing mini data set. So what we want to do, we need to choose the k, we need to find the neighbor, calculate the distance, then find neighbor, and we need to do the majority voting. Okay, so let our k be 3. Suppose we have set our k be 3, the value of k be 3. Now what we want to do, we need to find the distances. Okay, the distances between the new point. What is our new point? 160 comma 1. That is 160 gram. 1 is the texture of that fruit. This is our new point. We need to find the distance between the new point and all the points in the data set. Suppose now you can see it more clearly. Okay, so the new point 161. I mean 160 comma 1 and all the other points. Suppose this is fruit 1, 150 comma 1. The same data set is represented as a pair here. 151, 171, 140, 130 is written as pair to calculate x1, x2 to apply it in the formula. So here we are applying this Euclidean distance formula, and each distance is found. Root of 160 minus 150 the whole square plus 1 minus 1 the whole square, and we got it as 10. So the distance between the new point and the fruit F1 is 10. Then we found the same 161 comma 1 with 170 comma 1. So the both distance is 10. Then we found the new point with F3. What the distance is 20.02. And we found the new point with the fruit 4 in the data set. What it was 30.01. So second step is done. That is our distance calculation done. Then now what we want to do, we need to sort it. Okay, it's actually sorted for. Now we no need of any extra sorting. The order from the order itself, it is in the sorted form. Okay, so after sorting F1, F2, F3, F4, apple, orange, 10 is the smallest distances, 10, 10, 20, 30. Okay, we have sorted. Then what we want to do next? We have chosen 3 as our k before we started the algorithm, right? So we need to choose first 3 distances, that is this one F1, F2 and F3. Okay, that is chosen here, F1, F2 and F3. Then I took the label of that F1, F2 and F3, that is apple, orange. Here also look apple, orange. Now do for the majority vote. Who got more vote? Apple got, because apple got 2 count and orange got 1 count. This means that in our problem, majority vote was going to 2. Then we can say that for a input of 160 gram weight and a texture of smooth fruit will be an apple. So the new point will be classified as apple in this case. Okay, this is how our KNN algorithm works. I hope that you got an idea about how this is going on. Now, the most important thing we need to ensure is that if I am simply asking you, what is the parameter or what is the value that is controlling this classification? Can anyone guess? What value will be controlling this? In the entire step, we have seen distances, we have seen k, we have seen sorting, etc. What is the important thing that affect the classification? What do you think? Put it in the chat. Distance as important, but not much. But one peculiar value, if that value changes, everything changes. Yes, k value, correct. How we can know that the value chosen from us, the k is the good value? Suppose In our case, I think, suppose we had the data set as 10 observations. You think that in our this example, you suppose that we had 10 observation, 10 rows, and my k was 4. Then what happens? 2 tie is coming, right? The value of k is the one that is determining which class or which majority class we need to take. So very important thing in KNN is that very important, one of the very important thing, okay, we need to say like that, is that the value of k. Then how you will choose the value of k? That is our next consideration. Okay, so the value of k is a very big role because it decides how many neighbors we look at before predicting. Okay, so a small k means model become very sensitive and very larger k means model become more smooth. So we need to find a k in between very small and very large. In k cannot be very small, k cannot be very large. So we need to find a medium or a optimum value for k. There are many methods available to find k. There are hyperparameter tuning techniques. There are different techniques, cross validation techniques. So many techniques are there to find the value of k. Here in our session, we will be discussing one method and the most basic method, that is elbow method. Okay, elbow method. We will be choosing elbow method for finding the value of k. So then what is this elbow method? What this elbow method do? First I will discuss the step and I will explain it clearly when we come to the practical section. Okay. So in elbow method, what we are basically doing is that we will first calculate the error rate for k values. Okay, we will try out so many k values. Then the question is how many k values we want to try. Okay, there is 1 to infinity or 1 to 50 or 1 to 10. How many times we want to find the k values? For there is a simple assumption or an approach we take is that there is an assumption that the optimum k will be within root n, square root of n. The optimum k will be within square root of n, where n is the total number of observations in our data set. Suppose our data set has 100 observations. Suppose our data set have 100 observations, means 100 rows. 100 rows are there in our data set. Then value of n is 100. Total number of rows in our data set is n. Then it is an assumption that optimum k will be within root of n. That is root of 100. That is optimum k value will be within 1 to 10. Root of 100 is 10. 1 to 10. That is an assumption. So what we will do is that we will create a loop. We will create a loop in the sense we will iterate or we will take one by one each value of k up to what? Up to the root of n. Then we will check for each value the error caused by that k. Okay, we will check each value of k many times and we will build the model and we will check the error of that model for each value of k. Then which value of k is causing the least error, we will choose that k as our optimum k. That is the approach of elbow method. Okay, so when we come to the practical session, you may get more idea like that. We will be plot the elbow plot, and from that elbow plot, we will be finding the value of k. So, but keep in mind that elbow method is not only the option to find the value of k. There are so many methods, optimization techniques are there. It's a very big topic, advanced topic. If you are interested, you can go for that. There are cross validation techniques, hyperparameter tuning techniques, so many techniques are there. So in our beginner level, understanding your elbow method is more than enough. Okay. So next we are going hands-on. Hands-on in the sense we are going to apply the same KNN algorithm in our long prediction case study. Okay. So remember, in the last session, before the session on Friday, we have done SVM in the long prediction case study. In that same case study, we will be going to do this KNN also, and we will check how KNN is working in that our data set. Okay, so in Collab, as I already told in the last session, Collab, for each session we will be having a fresh collab. Okay, the collab will restart. So what we want to do before going to or before starting doing KNN, what we want to do is we need to upload the data set again, and we need to rerun all the previous cells. Okay, I have already said it before in the supported machine session about the same. So remember to rerun the cells in the collab when you log into the new sessions. Okay, for time being, and for time's sake, I will be using the pre-recorded version. You need to practice it your own after the sessions. All the materials and all the code, the complete case study is uploaded in the LMS. Okay, so let's look what happening step by step. Okay, before that, to track the number of total number of observation in the training data set, I have just print the shape of the train. What the shape means, you know now what is this. Then please say what this output means. 478,13. Our training data set has what? Yes, your rows and columns. And then for that means 478 rows and 13 columns. We have discussed in our data pre-processing sessions. That is dot shape means we are trying out to find the number of rows and number of columns in the data set. So we are for training we are using the extrain part. So I have taken the shape of extrain. For what? I need to create a loop. I need to iterate to a loop from 1 to certain number of limit. What was the limit? Root of n. Okay, so that for that I have just printed the shape of training data. And now the first step we have, what we are going to plan is we are going to find the error rate for each k, and we are going to plot that. We are going to visualize that error rate versus the value of k in a plot, in a line plot. Okay, so here in the first I have imported an library. The best practice is to put the library in our library session. For time being it is given here. What this library do is that it is given as import matplotlib.pyplot as plt. It is the, that is matplotlib is the library used for visualization in Python. The library used for visualization in Python. One of the library, there are so many libraries. Seaborn is there, Plotly is there. One of the basic library is the Matplotlib. So we are planning to plot a line graph. So we need the visualization library. So I have imported Matplotlib here, and I has renamed it as PLT. I have given a nickname as PLT here. So then wherever I refer Matplotlib.pyplot, I need to only give PLT. Okay, now we also need to create that our KNN neighbor classifier, right? So that library also need to be imported. Okay, here I have imported that. Look, from sklearn.neighbors, import kneighbors classifier. It is the library kneighbors classifier. Okay, from the sklearn library, please import kneighbors classifier. That is our KNN algorithm. Okay, so okay, so we have imported the library. Now, as a first step, I have given as error equal to an empty square bracket. It's just an empty square bracket. 2 empty square brackets I have given here. Okay. What this means that we are here creating a list. We are creating an empty list. There is no elements in that list. Okay. We are creating an empty list here. What this empty, for what we are creating this empty list? We need to track the error for each value. Okay, for that, for tracking that error, we are creating an empty list here, and I am just naming that list as error. Then what is a list? Means that list is a general data structure in Python, and as a beginner or an new to programming, anyone is there, just think it like a bag. Okay, you can add anything in that. Any number, strings or anything, integers, floats, anything. That is, we will store in our case. What is the aim or the use of this list is that we are going to store error of each k in this list. Okay, now I have given a loop here, one for loop. For loop, I have seen that for k in range of 1 to 22, I am going loop is nothing but just remind it as like this. Do something again and again. That is called loop. Do something again and again for different values. For different values, do something again and again. That is the concept of a loop. So here in Python, there are so many loops: while loop, for loop, while else loop. Many loops are here. I have used here is the for loop. What this loop is saying that for k in range of 1 to 22, it means that you need to create a loop, and that loop must do something. Okay, what to do? The loop must do these much steps. Okay, for how many values of k? K equal to 1, k equal to 2, k equal to 3, k equal to 4, up to 21. Okay, 1 minus this, if we are given here 22, then k value will be ranging from 1 to 21. If you are giving here 25, k value will be ranging from 1 to 24. 1 will be less always. Okay, so here then in this loop, we are testing k values from 1 to 21. Why only up to 21? Because root of 478, it's around 21.8. So we need to check. We are assuming that our optimum k value will be within 1 to 21. So we need a loop from ranging from 1 to 21. So I have given a for loop with 1 to up to 22, because in the for loop logic, upper limit minus 1 will be the iteration. Okay, from 1 to 21. Now, for each k, we need to create what? Our KNN classifier. That is our KNN algorithm object. So, in that object, we want to specify what are the neighbors. That neighbors is given as n underscore neighbors. So, what it does is that for k, first iteration, for k is equal to 1, first model object will be created with n neighbors equal to 1. Then we will give the training data, our x train and y train, and we will build the model for k equal to 1. We will predict what? We will predict it with x test, exactly the what as we have seen in the SPM session. Okay, so here model the predict, we are giving the test set. That is our questions for the answer. We are giving the x of the test set, and what we are going to do is that we are going to append, we are going to add the error of each k to the error list. Okay, for that we need to find the error, right? But we have the formula to find the accuracy score. How the accuracy score is found? The actual answers and the predicted answers is given to the accuracy score function, and it will be giving an accuracy. Suppose suppose the accuracy is 0.8, then what is the error? 1 minus 0.8 is the error, right? So what will be? We are just calculating that 1 minus accuracy of by testing comma pred. That is 1 minus accuracy score will give us the error. That error I am appending it to the error list, the empty list. So what happens here is that first the k value will be 1. For k equal to 1, our model object will be created. For k equal to 1, a KNN model will be trained using X train and Y train, and with that model we will test or we will predict the value of X test, and that predicted values will be in pred, and we will find the accuracy score by giving the correct answers, the widest and the predicted values, and we will find the error by subtracting the accuracy score from 1, and we will add that error to error list. Then in second iteration, k will be 2. For k equal to 2, our model will be built. Again training happens, again predicting happens. For k equal to 2, our error is computed and is added to error. Then k equal to 3 done, k equal to 4 done, up to how many values it is done, up to 21. The same process will be done, and our error list after completing the entire loop, it will be having 21 error values, because we have checked 21 k values by building each model. Okay. Now, after this step, we are going to plot our k value with what? Our error value. Suppose we are planning value of k in x-axis and the corresponding value error in y-axis. That is our what? A. So we need to plot a xy what? We need to plot a error graph. Okay. So here plt dot plot range 1 to 22 comma error means we are going to plot. Plt dot plot simply means draw a line graph. Okay. For line graph, we are giving this plt dot plot. In line graph, in x-axis, what we want to come? We need to come. We need to have a range from 1 comma 2 comma 3 comma up to 21. Okay. That is x-axis. I need to go from 1 to 21. So that is x value, x-axis values. And in y-axis, what we want to plot? We want to plot error. So I have been given this as plt dot plot x-axis value and y-axis value. What is this error? Error is the list. The values in the list will be the error of each k values in after training. Okay, then if I need to give a label for x-axis, suppose this value of k, this label here in the chart, I have been given plt.x label, the label you need to show. Then in y label, y-axis label is plt.y label error rate, that is this one. Then I am just giving a plot here, a title here, elbow method for choosing k. What I have given as plt.title elbow method for choosing k. Suppose if you want to give the interval as 2, that like 1, 3, 5, 7, you do not need 1, 2, 3, 4, 5, 6 up to 21. You need an interval of 2, 1, then 3, then 5, then 7. That is tick. We will say it's just ticks. Where the tick need to be controlled in x-axis. So the x-axis tick must be 2 interval that I have given as from range 1 to 22 with a 2 interval. 2 interval means first it will be 1, then plus 2, then 3 plus 2, then 2, 2, 2 like that. So this means this x6 means the x-axis values range interval. Then we are saying we are asking to show the graph. Without this code, the graph will not be shown or displayed. So it is given as plt.show. So we have plotted the line graph which shows the value of k versus error rate. And from this graph, can anyone guess what is the best k value? Anyone guess? Value of k versus error rate. Just look for some time and just guess which value the k is, which value of k the error is low. Any answers? Oh, yes. 12, 12, 12. Correct. Correct. Yes, here we can see clearly that at value of k equal to 12, our error is low. So we will be fixing our best k as 12. Then what we want to do next? We have chosen the k. Okay. Then we need to build the final model with that k. That is given here. The exact thing what we done for what SBM. The same steps, only the difference is in the object we are creating. Here we are creating KNN. KNN bus classifier. Now for NIB, we need to give 12. Why? We have found the best value of K as 12 here. So we have given 12 directly. For that object, we are trying to find the train the model using X train and Y train using fit function, and we are giving the X test and asking the model to predict, and that predicted result are there in KNN underscore pred, and we are finding the accuracy score by giving the correct answers and the predicted answers, and we have got accuracy score somewhat as so 0.758333, something like that. And the other steps are very simple. We are finding the confusion matrix here. Okay. If I ask, can you, anyone can decode this confusion matrix? What is this 8? What is this 27? What is this 2? What is this 83? Same as what we discussed in SVM. No other, no extra info to say. Just to try out. Anybody can recollect what this 8 says, what this 27 says, what this 2 says, what this 83 says. I will make it more simple. I will make it more simple. You sometimes you may be PPT and it will be something maybe confusing your position. I will make it very simple. The question will be simple. Now the question is, how many corrected predictions are given by the model from this confusion matrix? How many correct predictions? Just say which one plus which one, or give the number count. Yeah, Aparna is saying 8 plus 83. Okay. Others, any other answers? Or going with Aparna? Yes, Aparna is right. It's 8 plus 83. Always remember that when a confusion matrix is printed, the diagonal, sum of the diagonals will be always the correct predictions. Diagonal, main diagonal. 8 and 83 is the main diagonal, right? So that are the sum of that corresponding diagonal elements, main diagonal elements will be the correct predictions. Okay. For to recollect, I will explain once again this confusion matrix. As you can see that in sklearn, this is 0, 0. That is, actually it is 0 in the data set, model predicted as 0 itself. So remember that in sklearn, the first position will be TN. That is true negatives. Okay. Here in our confusion matrix, remember first rows, that is this first row shows the actual class 0 and the second row shows the actual class 1. Okay. Then what 8 means? 8 loans were predicted as not approved. Correctly predicted as not approved. What not approved? Loan not approved. Okay. So 8 loans in our data sets are correctly predicted as not approved by our model, and 83 loans were correctly predicted as approved, that is true positive, in our data set by our model. And what are the errors? 27 and 2 is the error. For simply, you can just remember, like you in your mind, you map it like this. This is 0th row. This is first row. Then This is 0th column. This vertically. This is first column. Then very simple. 0, 0, total 8. Actually, it is 0 in the data set. Model predicted 0. Then how many are there? 8. Actually, it is 0 in the data set, but model predicted 1. Then that is wrong, right? So false positive. So how many are there? 27. Here exactly like that. 1, 0 and 1, 1. So the diagonal element, always the main diagonal element will be the correct one. Correct prediction. Okay. So now we can just compare this KNN with our SVM. In SVM, I think we have got something around 0.8 like that. Yes, in SVM, linear SVM, and in RBF, we have got around 0.8. That is 81% of accuracy, and others not. But when compared to KNN, for our data set, SVM is functioning, or SVM is performing much better than others. Okay, why this SVM is better? Because sometimes our data may be matching the concept or the theory of the SVM. We don't know. For different data sets, this will be behaving differently. It does not mean that SVM is better than KNN, or KNN is not well performing than SVM. It's nothing like that. According to the data, according to the pre-processing steps we are doing, the algorithms and also the behavior of the data and the accuracy changes, and also we can tune this, we can hyper tune this, we can adjust this one by using, there are so many parameters available, and it comes under the different advanced topic like hyper parameter tuning, and there are so many methods like that. If we use that such boostings or any other algorithms etc, we can fine tune these accuracies, but for the beginner level we are trying to give you the knowledge how the ML works, how the actually the algorithm works, and what are the basic steps to predict and make the model for the problem, real world problems. So always remember, different models behave differently on the different data sets. Okay, different models behave differently on different data sets. So our job is to check, compare, research, and find the best performer. Okay, so we are at this beginner level, so all the concepts in SVM and KNN are discussed up today, and before we stop day 4, as usual we can have a quiz session. Okay, there are simple questions. I will copy paste the questions in the chat. Okay, this is a scenario. Read the scenario and put the option in the chat box. The scenario is Alice wants to predict whether a new customer will buy a product or not. Okay, she uses KNN algorithm with K equal to 5. 3 closest neighbors bought the product, but 2 did not buy the product. Okay, then what will KNN predict for the new customer? Whether the new customer buy the product, not buy the product, or any random values, or the our KNN cannot predict. What is the option? A, B, C, or D? A is the correct answer because K is 5. Majority voting is, I think, 3 versus 2, right? 3 said that product will be bought, then A is the answer. That is, the new customer will buy the product. Yes, good. Now the second question. It's very simple. What is K in KNN? What is K in KNN? Options are option A, the number of features in the dataset. Option B, the number of neighbors considered to make the prediction. Option C, the total number of data points. And option D, the learning rate. Very simple question. I think all of you can answer this question. Yes. Option B is the correct answer. K is the number of neighbors considered to make the prediction. Yes, good. Now the next question. I think it's the last question. Yes. So this is something not tricky. It's very basic. Just find the order, the steps of KNN in correct order. Read it and do it. I think if I read it, it will be very messy. So you just read it and put the correct option that says the correct order of steps in KNN. Yeah, Vinaya, option D, others. Yes, you are saying option D. What's option D? Choose K, calculate distances or distances, select K neighbors, and vice majority. Yes, correct. Option D is the correct answer. First, we need to choose the K. Then we will calculate the distances. We will solve the distances. Then select the K nearest neighbors. Then according to that K neighbors, we will we will do a majority vote. Yes, correct. Okay. Good. There are more questions, and those questions are added in the LMS. It will be come according to after each sessions. I think KNN and decision trees as a one quiz. It will be uploaded. The SVM QC is uploaded, and also the machine learning QC is also uploaded. You need to attend the quiz in order to get the certificates. So periodically, when you are fresh with the topics, when you are remembering the topics, just attend the quiz. Okay. So with that, today's session was very short because algorithm was very simple. So we conclude day 4 of our webinar. Today you learned what? You learned KNN, you learned about K, you learned about K elbow method, and also we have seen how long prediction case study works with KNN. So our next session will be on tomorrow at 7 p.m. And tomorrow we will be discussing another algorithm named decision trees. It also has some max in that. So we will be seeing decision tree tomorrow. Before wrapping up, as usual, please fill the feedback form. Okay, I will put it in the chat. Okay, please take a while to fill the feedback form, and meanwhile, if you have any queries, you can put it in the chat box. Okay, fill the feedback form now, and if any queries, okay. Miss, after we finish the course, the internship will start. So this is also the part of it. This is the part of internship. Okay, you after each session, you need to check the LMS. Okay, different courses or different sessions will be having quizzes. There will be task for each session. I think Power BI task is uploaded, and after our session also, we will be having a task in machine learning. And in coming sessions, after each sessions, we will be having task uploaded. The task you need to do will be uploaded in the LMS. You need to submit the task, and your task will be graded by the trainers. And according to that grade, you will be getting the certificate. Okay, it's a part of internship. Not all the sessions have the task, but many of the demonstration sessions will be having the task. I think our Power BI task is up in the LMS. You got an idea. I think you got an idea. So the answer is this is also the part of internship. There is no extra internship start is there. Okay. Is there any last day to submit the task? Yeah. Probably we are giving the time up to January 31st. Okay. 2026. Okay. Before that, you need to complete all the tasks. So periodically check the LMS, there will be task uploaded, and for our machine learning, it will be coming tomorrow. So after tomorrow's session only, it will be. Okay, fine. Thank you. Any other questions or? Looking to the LMS, there are clearly mentioned some guidelines in the LMS. So please read it carefully. To whom to reach out if you have any questions regarding the task, if you have any doubts regarding the task, the mail IDs of the contact person is given in the LMS. So read that. Also, there are some rules or guidelines given in the LMS about how many times you can submit, how many times it will be reverted your task, and also if you are copying it from some maybe from same colleges, right, then or it will be giving same task files, then what will be the procedures, etc. Many guidelines are given clearly in the LMS. Read it before you uh, submit the task. Okay, any other questions? You are unable to log into the LMS, could you please help me? Okay. Can you please put your email ID in the chat and your name? In direct, not in public, you just directly message me. Okay, one who have posted this, I'm just not sure about your name. What you want to do is you just, I will give my mail ID. Okay, just post your issue to this mail ID. Okay, alphy.mathew@ipsrsolutions.com. You have given that. Thank you. Okay. Okay, we'll be in track. Okay, we will reach to also post a mail to this mail ID. Okay. No issues. Okay, fine. So if no more questions, we can wind up for today. And thank you so much for your energy and participation on this day 5. And on day 5, we will be continue our journey from with the next algorithm, that is tomorrow. Okay, so until then, revise the concept and keep experimenting. Practice only make you your practice only make your build your skill. Okay, so thank you everyone. See you all in the next session tomorrow. Thank you once again. Happy learning and bye. Thank you.